Winding resistance test. Winding resistance test is performed in resistance test tab. In this tab, by injecting DC current into CT secondary and measuring the voltage through input and dividing the voltage by current, the DC resistance or R measured is calculated. Note that in the software, there is a row by default. If the CT has more tabs, by right-clicking and selecting Add, you can make as many tabs as the rows and test each tab. To perform this test, you need to enter the current and time in a state settings section in iTest and a state time fields respectively. The current limitation is 32 amperes, but a 5 ampere current for 5 ampere CTs and a 1 ampere current for 1 ampere CTs would be enough. After entering the information, you need to set the wiring according to the figure. Note that by double-clicking on the picture, you can maximize it. In this wiring, first short circuit IA1 and IB1, then parallel IA2 and IB2 with the capacitor, and here you need to connect IA2 to S1 of the CT and connect IB2 to S2. The reason for using the capacitor is to compensate the self-inductor effect of the CT. There are three 1000 microfarad capacitors in this box, and the red port is the positive polarity, while the black port is the negative polarity of the capacitor. To measure the DC voltage, you should connect the input 1 to the CT and further from the current connectors. Then connect the output current, which has been paralleled with the capacitor, to the CT. Note that to perform the test, you should right-click one of the rows and select Apply Test. By doing this, the current and time setting, as well as the hardware setting related to the hardware configuration, including the outputs and binary analog inputs, are adjusted automatically. In Analog Output tab in Hardware Configuration section, you can see that the wiring settings is set at 32 ampere with a 400 volt amperes burden, and the binary analog input 1 is activated to measure the voltage. To better analyze the test, you can use Table View, Detail View, and Signal View. After opening Table View, you can see that two zero frequency states are made in accordance with the information of a state setting. The first state is used so that the CT current exists the transient state and turns constant. The second state is used to measure the current and voltage and to measure the resistance. Now, if you wish to view more details, use Detail View window. Performing the test and analyzing the results. After wiring, 1 ampere and 2 seconds are entered as test current and time, and 10 Rmeas accuracy is selected as time period. By right-clicking on one of the rows and selecting Apply Test, the test is initiated. Note that in Signal View, the waveform of the actual current and the voltage measured by binary input is viewable. By using Signal View and the recorded current and voltage waveforms, it is possible to analyze the test, and by using the actual values and the recorded voltages, examine the connection of the connectors. After the test is finished, by selecting the row in result, it is easily possible to view the test results. The results include VDC, the injected current, R nominal, the resistance measured in the current temperature, the resistance measured in the reference temperature, and R deviation of the difference between R correction and R nominal in percentage. In correction factor is calculated in accordance with ambient temperature and the reference temperature, as well as the material of the coil. The information of this temperature is entered in reference winding field in test object, and R correction is calculated by multiplying the R measured value by the correction factor. Sometimes it is possible that in the CT test sheet, the resistance is measured in a temperature other than the one mentioned in the plate. If you wish to enter this resistance, you need to check R manufacturer. By doing so, this resistance and its temperature are considered as the reference. By doing this, in the Resistance Test tab, Temperature Manufacturer column is added to the results table. In this column, the temperature measured by the factory is calculated. In the end, after performing the test, if R correction is smaller than R nominal, the assessment is passed, otherwise it fails. After the assessment, you should add the results to the report via Add to Report in Instrument Test. Also, if you wish to add some specific parts of the report or delete or edit the report, you can use the Add to Report cog. By clicking on it, you can check the items that should be added to the report, or if you don't need them, you can uncheck them. Note that after performing each test, the results are not automatically added to the report, and it is necessary to add the results to the output report by selecting Add to Report after each test and before clearing the test. In performing the test, note that in voltage measurement mode, you need to select one of the radio buttons in accordance with the maximum resistance specified in maximum resistance column. If during the test in the default mode an overvoltage error appears, select binary 01 with a maximum of 8 volts. If the measured resistance is less than the maximum resistance of the binary 10, use the input 10 for more accuracy. If you also wish to use a different wiring for the current, select Apply Test at least one time before. Then, check Don't Change Hardware Setting and select your desired wiring and hardware configuration, and then select Apply Test again. Two notable points are that Error Other shows that there is a problem in the wirings, or resistance is too high that the device is not able to provide the burden to inject the current. Therefore, if this error appears, examine the actual value of the current in the signal view. If the current is injected, but its difference with the set current is too much, the wiring resistance is too high, and if actual current is 0, the route is open. If the resistance is too high, the current should be decreased, and the actual current equals 0, you need to examine the connections. The other point is that if the measured voltage is 0 or has too high tolerances, it means that the connectors are not connected correctly.